Hi guys! In this tutorial we will investigate polymorphism in JavaScript ECMAScript 7 specification. But at first let's go back to types of inheritance because it has really important relationship with polymorphism. On the left side of a slide is type that we investigated in previous videos. Is called is_a inheritance. It means that instance of any child class is still a type of a parent class, or from JavaScript syntax's perspective, it's better to say instance of parent class. And on the right side of a slide, the other alternative approach is called has_a inheritance or composition. In this case, inheriting class B is not an instance of a superclass class A, but has a property with an instance of an inherited class. Instances of both types of inheritance contain the same functionality but different interface to access it. Both approaches can be preferred in different situations. Composition gives different weight of flexibility in extending class, which means that it is better to compose what an object can do than extend what it is. Type languages with ability to use interfaces still provides an efficient way to simulate is_a principle in composition. But at this point JavaScript doesn't have support of interfaces. Is_a inheritance provides abilities to implement polymorphism principle. Let's try to describe what is polymorphism in few definitions. Polymorphism in object-oriented programming is an ability to create a property, function, or an object that has more than one realization. The other definition can be that polymorphism is an ability to substitute classes that have common functionality in sense of methods and data. In other words, it is an ability of multiple object types to implement the same functionality that can work in different ways, but supports the common interface. So, for example, the function that expects a superclass instance as an argument can work correctly with subclass instance as well, without function needs to know about any of the subclasses. Let's look at real-life example of polymorphism. If you learn driving one car, you'll be able to drive on any car. It doesn't depend on car brand or inner implementation. It has the same driver interface. The same in programming. If your code is able to work with one implementation of interface, it should work with the other that has the same list of methods and properties. In case of dynamic binding or late binding, we don't have to know the exact type. It's enough to be sure that instance will be of some type or has some superclass that contains needed functionality. In this case, the exact behavior is determined at runtime. That important ability is a reason of using polymorphism, which simplifies code in case when many objects have the same interface with different implementations. Let's discuss some code example. We would like to create family of shape classes with common interface to work with each of them in the same way and be able to create more shape types in future without updating code that handled them. For that, we will create some parent class called shape and, for example, three child classes: circle, rectangle, and triangle, with one method that will return shape area based on shape configuration. Also, we will add some code that works with instances of those classes. Okay, let's try to implement some basic class shape. It will be very simple. It will be something like abstract class. We'll have just area method, which will return 0, I guess. And now we can create few shape classes that inherits this class. For example, we'll start with class circle that extends shape, extends correctly, I guess. Okay, and it will have some constructor method which will receive, I think, just radius. It's enough. This radius, for our purposes, it's enough to have only radius. And it will override the area method of shape class. Okay, and it will return just math.p times this dot radius squared. So new ECMAScript syntaxes gives ability to use the next feature to get a squared value of radius, just double asterisk. Okay, let's continue creating our classes, and the next will be, I think, rectangle. Class rectangle, hope it's correct, and extends shape. Okay, and constructor will receive, I think, width and height. This dot width and this dot height. Okay, let's override area method, which will return something like this width times this height. Okay, so at this point we already have two shape classes. And now let's create some function that works with these instances. So let's create function something like cumulative function, cumulate shapes, that will receive an array of shapes and will be able to return its area. So for example, we'll have some shapes array, and we will be able just to accumulate it. For that purpose, we will use reduce function. So we will run through the elements with reduce function, which will have a callback. In callback we will have cumulative value, sum, and we will have, I think, shape, and we will return the sum plus shape dot area. Okay, and default value should be 0. Initial value should be 0. Okay, so at this point, and we should return it. Okay, return the value. Okay, and now we can create a bunch of shapes. So, for example, shapes array, it will have new circle with radius 3. Okay, and new rectangle with width 2 and height 3. Okay, and that's all for now, and we'll try to check your function works. Give shapes, and we will pass a shapes array here, and we'll try to console log it. Console.log this value. Okay, first of all, I will just try to run it in Node. Not sure if everything's correct, but hope. Shape. Okay, something wrong. What is wrong with that? This data, of course, we forgot to execute in constructor super method, super function, so we have to call it in both child classes. It's important to call it in case if you are extending some custom class like shape here. Okay, let's try one more time. Okay, now we have some area. Hope it's correct. Okay, this is correct value. I even tested on calculator. So let's extend our application with one more shape class. For example, let's create class triangle that extends shape class. Okay, inside of it we will have constructor which will receive base, side and height. Okay, so we will have we will run super method, and then we will create properties base and height. Okay, and we will override our array method. Area, and this method will return, I guess, this dot base multiply on this dot height and divide on 2. Okay, so here we have a new shape, and we will try to extend our shapes array with new component triangle with base 3 and height 4. Okay, let's try to check what we have now in cumulative shapes area. Okay, we have missed in constructor set initial value for height, and let's try one more time. Okay, looks like we have a correct value. Of course, we can have here many shapes as we want. We can add some new circle, one more circle with some radius 3, or we have a 3, so with 2. And after that our value should change. It works correctly. So what will be good to do is also to do something with class shape, because it doesn't have any functionality at this point. So what I would like to add, I would like to override toString method, which is used from the object.prototype. Okay, but before it I would like to extend our cumulative shapes method, and one of the things that we haven't handled yet is, for example, if I will pass just value 5, what we will receive, and we have some kind of error because 5 doesn't have any area method. So let's check it inside of the reducer callback. So we will have to extend this function. Okay, and inside of this function we will check instance of shape. So if shape is instance of shape class, then we can of course calculate this value. Okay, let's try to do it. Otherwise we can return just some, or I'd like to throw an error in this case. Throw an error where we will message bad argument shape. Okay, let's see what do we have now. Correct, we have an error, and inside of this error we have our exception, bad argument shape. So let's remove this incorrect argument. And what I also would like to do, I would like to throw in console information about shapes that were calculated. So what I would like to have, something like this: console.log. I will use template string, and here for example shape, and something like shape to string. Okay, it will be its name, and area will be calculated from shape.area method. Okay, let us check what we will have now. Okay, we have just object, and the reason for that is because toString method is used from object.prototype implementation, and it returns just object. So we would like to override toString method inside of the shape class, and in this case all the children classes will be able to reuse it. So what I would like to do, just to add this method here, and this method should return name of string. But what I can do, I can use this, I can use prototype of this, because in prototype of an object we have a constructor which has instantiated this object, and at this point I will use object get prototype of this, and here is constructor method, and this method has name. Okay, let us check what we have now in console. Cool, looks like it works. So overriding toString is also using polymorphism principle. So we have object.prototype.toString function that is overwritten here in shape, and each child class can reuse it. So that's all that I would like to talk about polymorphism, and you also have to look more videos or read an articles, and the most important thing, you have to practice to create new projects and try to use polymorphism principle in these projects. So thanks for watching, and I will appreciate if you will leave some suggestions, some comments, some corrections, and if you like it, you can subscribe, you can like the video. I thank you and see you later. Bye.